Question 5 says a particular rocket taking off from the Earth's surface uses fuel at a constant rate of 12.5 gallons per minute. The rocket initially contains 225 gallons of fuel. Determine a linear model in y equals ax plus b form for the amount of fuel the rocket has remaining y as a function of number of minutes x. Okay, so we're going to see in this case that it says here uses fuel at a constant rate of 12.5 gallons per minute. And so that's going to be our slope. And initially had 225 gallons of fuel. That's our y-intercept. But now it says here, determine the linear model for the amount of fuel, it's the report, for the amount of fuel the rocket has remaining as the function of number of minutes x. Now, it uses fuel. So it uses fuel. It means in this case that the rate is going to be negative because it's taking away from the total fuel. So we see in this case y is equal to mx plus b is the form we're using. And so therefore we're going to use here y is equal to, well, ax, let's say ax plus b. So here our slope is going to be negative 12.5 x plus 225. Again, why is our slope negative? Our slope is negative because it is taking away from the total amount. It is taking away from the total amount. Okay, and so we continue here. To the right is a general sketch of what the graph of your model should look like. Notice that it starts off at A and ends at B. So using your calculator, determine x and y intercepts of the model and label them on the graphs of points A and B respectively. Well, we know in this case, we'll begin with using our function when x equals 0. So we have y is equal to negative 12.5 times 0 plus 225. We get a y value of 225, giving us a coordinate of 0, 225. And that's important because that's going to be the coordinate we have here. So let's type in that coordinate. Maybe here we go. Okay, so the coordinate here will be 0, 225. That's point A. Now we want to solve for point B. Okay, and to solve for point B, we're going to do is, we're going to basically set our x value equal to 0 and solve for y. So that means y, our y value for 0, I'm sorry about that. For B, we'll set y value to 0 because that's what we have, or we're totally finished with the amount of fuel, and we want to solve for x. So that's quite the switcheroo in this case because we're finding the x-intercept. To find the x-intercept, we set y equals 0 and solve for x. So in this case, I'm going to subtract 225 from both sides. And we get neg 225 is equal to neg 12.5x. We divide both sides by 12.5, neg 12.5 actually. And so we use our calculator, and you pull out your calculator now, ladies and gentlemen, and we're going to, in this case, take the value of 225 and divide by, well, negative 225 and divide by 12.5. Although if you decide to, in this case, just set them both to positive, it will be okay because the negative of a negative would be a positive value. So we have x equals to 18 minutes, 18 minutes. And so our coordinate for B, in this case, would be 18, 0. Okay, so here we go. So determine x and y intercepts. We did that. No, our y intercept was 225. Our x intercept was going to be 18. So again, we got the coordinate here of 18, 0. Should have wrote it down first before I typed it, but it's okay though. All right, so those are the two coordinates on the graph. Now for part C. The rocket must still contain 50 gallons of fuel when it hits at stratosphere. what is the maximum number of minutes the rocket can take to hit the stratosphere? Show this point on the graph by also graphing a horizontal line at y equals 50 and showing the intersection point. Okay, so we say in this case that it must contain 50 gallons of fuel when it hits the stratosphere. All right, so in this situation, our y value has to be 50. And so we are going to now, in this case, we're first going to set the y value to 50. Okay, and so what happens from here, we'll solve for the x value number of minutes. So we have negative 12.5x plus 225. All right, so again, we're going to subtract both sides by 225 because we'll isolate x by itself. And so on the right side, we have negative 12.5x. 5. And on the left side, well, negative 225 plus 50, same as, well, 225 minus 50 is going to be 175 with a negative value here. Okay. And then we're going to divide both sides by neg 12.5. And using our calculator, we're going to find the following. We're going to find neg 175 and divide that by, sorry, ladies and gentlemen, I'm having a little bit of trouble here. Neg 175 divided by neg 12.5. And we get a total of 14. So x equals 14 minutes. And so we want to do, so the maximum number of minutes the rocket what is the maximum number of minutes the rocket can take to hit the stratosphere? Well, we know in this case, all right, that there are 14 minutes left, in this case, 14 minutes, and when 14 minutes time-wise, there are 50 gallons of fuel left in the rocket. This means, in this case, that the rocket can basically travel up to 14 minutes before it must have 50 gallons of fuel. So the maximum number of minutes the rocket can take to hit the stratosphere is going to be 14 minutes. So we'll just write this down here. And then in this case, make sure I get my font here. Okay, here we go. So the maximum number of minutes it can take the rocket to hit the stratosphere is 14 minutes, because after the 14 minutes, it will have less than 50 gallons of fuel. And so the question is also asking us to draw a horizontal line. Well, if this is 225, okay, and this is 0. 50 should be, well, let's see now, somewhere over here. All right, I would say here's my horizontal line here. Okay, and so here's my horizontal line, and at this point intersection, which we'll kind of mark in red, hope it comes on red, right here, will be a coordinate of, in this case, 14, 50, meaning after 14 minutes, there'll be 50 gallons of fuel left. Okay? All right, ladies and gentlemen, hope this is helpful to you guys, and this is the end of our review for the linear modeling homework review, part 2. If you found the video helpful, please give it a like, as well as subscribe to the channel if you have not done so already. Please leave questions and comments in the comment section below, and as always, be safe, ladies and gentlemen. Take care.